Hello everyone, this is Beth Wadham from the Association for Contemplative Mind in Higher Education, and welcome to our March webinar, The Neuroscience of Somatic Attention, a key to unlocking a foundational contemplative practice for educators. We're here with Dr. Katherine Kerr from the Department of Family Medicine at the Warren Alpert School of Medicine and the Contemplative Studies Initiative at Brown University. Kathy received her BA in American Studies from Amherst College and her PhD in History and Social Theory from the Johns Hopkins University. So she's a scientist with deep roots in the humanities. In 2006, she received a K Award from the National Institutes of Health to undergo retraining as a neuroscientist. And she has focused on the effects of meditation on somatosensory cortical maps. Since that time, she's used neuroimaging and behavioral approaches to investigate mind-body therapies, cortical dynamics, and attention, especially attention in the touch modality. Before coming to Brown, she was director of the program in the Neuroscience of Meditation, Healing, and Sense of Touch at the Osher Research Center at Harvard Medical School. She began the appointment at the Department of Family Medicine at Brown and has been working with the Contemplative Studies Initiative there last year. She taught meditation and the brain with Dr. Willoughby Britton during the summer and the cognitive neuroscience of meditation in the fall semester. She was also gave our research talk at the annual conference of the association at Amherst College last year. Her current research investigates how physicians and other busy professionals can incorporate somatically oriented mindfulness practices into their daily life, a very worthy enterprise. And thank you so much, Kathy, for offering this webinar to our network. And now I'll hand over the presentation to you.
Great. Thank you. Can you hear me, Beth?
Yes, you sound loud and clear.
Excellent. Okay. So thanks to everyone in the ether. It's wonderful to make your acquaintance. So I'm going to talk today about embodied experience, especially the experience of body sensations, including sensations of touch, and how that might be relevant for understanding mindfulness practice. And to start out, I'm just going to reflect on my own embodied experience right now. I'm in Providence at Brown, and it's incredibly warm outside. And the air conditioners have not yet adjusted for that. So everybody just sort of reflect on what you're experiencing right now for a second, and what are you sensing, and what are you feeling, and what does it feel like to just be listening to this webinar. And as you're reflecting on that, maybe focusing on the breath a little bit in the belly if that's comfortable, let's just get started and talk about the neurobiology of mindfulness and focus on sensory mindfulness. So I'm going to talk a little bit about some concepts, body space and presence in mindfulness practice. I'm going to talk about that at the end. I'm also going to really briefly describe a hypothesis about the neurobiology of presence and its relevance to contemplative education. So first, let's talk about the neurobiology of mindfulness. And we're really going to talk about entering a sensory world. Mindfulness training is now being incorporated into a lot of different health settings. And I think there may be, in the general public, some confusion about what mindfulness training involves. So let's sort of focus on that for a second. The most famous form is mindfulness-based stress reduction. And that was developed by Jon Kabat-Zinn, and probably most folks are familiar with that. And Kabat-Zinn described mindfulness training, said the purpose of this is to learn how to pay attention in a particular way on purpose in the present moment and non-judgmentally. What does that mean? Concretely, if you look at what people do in mindfulness-based training programs, their main focus is on body and breath sensations. Through 3 meditative techniques, the body scan, sitting meditation, and yoga. And what's important about these practices and the way they're practiced, the way it's taught, is that there's a focus on body and breath related sensations at a very high level of detail. And that's really meaningful when we're thinking about what brain mechanisms may be involved. So here is the first day, the opening meditation in the 8-week mindfulness training program. This is what people are asked to focus on. They're doing what's called a body scan, and the instruction is they're told experiencing the big toe in the left foot, and if you can, the little toe, not moving them, but just feeling them individually, and perhaps the toes in between. And the folks who are listening to this webinar it might be useful for you to actually try to experience the big toe right now, if you can. So why would there be this focus on such a high level of sensory detail? And we know mindfulness reduces the risk of depression, reduces pain in chronic pain patients, it improves immune function. Why would this particular sensory focus, how would it reduce the risk of depression? What is the mechanistic link? That's what we're going to talk about today. Now, this is something that I ran a study of mindfulness-based stress reduction in 2008, and one of my participants, she was asked to describe the most salient aspect of her practice on a particular day, and this is what she wrote. Nostrils felt very cold when breathing. Think about how detailed that description is. It must be important. We see it also in the Buddhist literature, and we see it in many qualitative studies of mindfulness, a very high level of sensory detail. Why? How does it reduce the risk of depression? So let's talk about the brain. What does somatosensory mindfulness do to the brain? And please pay attention. I'm going to talk about two attention circuits in the brain today. Circuit 1 is the lateral prefrontal cortical circuit, and this modulates sensory attention. Okay, this figure on the screen is the lateral prefrontal cortex. What this means, what I'm going to tell you about the science of this is that when you pay mindful attention to a sensory stimulus like the breath, you're actually exercising this lateral prefrontal circuit. So there's a study done by Norman Farb and Adam Anderson in Toronto in 2007. It's really, I think, a very beautiful study. And what they showed was that there are two different brain networks. And this is something that we actually see throughout the brain literature. There are two different brain networks. When one brain network goes up, the other goes down. These brain networks are competing. Here are the two brain networks. There is the brain network that is used for rumination and self-judgment. That's the medial prefrontal network. And there's the brain network that coordinates attention to present moment sensations. That's the lateral prefrontal network. And what we found was that mindfulness practitioners, people who learn mindfulness, actually, what did they practice? Well, they learned to focus on their breath and body sensations with a high level of detail. They learned to ask themselves, where is that sensation precisely? What are the qualities that it has? What sensory qualities? And when these questions are asked, the network switches from the medial to the lateral prefrontal network. Does everybody understand these two networks are competing, the rumination network and the sensory attention network? When you enter a sort of sensory attentional focus, you are actually turning down the volume on the network that engages in rumination. That's the first attentional circuit that we're going to talk about today. So what happens when you do that? Well, people who get stuck in this rumination circuit, they're the ones who are likely to endorse, to say something like, I spend a great deal of time thinking back over my embarrassing or disappointing moments. These are people who are thinking about the past, thinking about themselves in the past, or projecting themselves into the future. And when that's happening, this medial network goes down the midline of the brain, is more active. And what we found was that in mindfulness practitioners, we know in mindfulness practitioners that they are less likely, after training in mindfulness, less likely to ruminate. Their tendency to ruminate decreases. And what FARB seems to show is that this subtle awareness of body sensations that these people learned took them out of the rumination network. So if you look at the figure, the brain figure on the right, the lower right, the orange blobs are the lateral attentional network. That's the network that runs along the side of the prefrontal cortex. And then the green blobs are the medial prefrontal cortex. That's the middle line. And that medial prefrontal cortex is a very interesting area. We could talk about that at some length. It's very activated in self-related cognition, which can be highly useful if you're needing to imagine what would that be like for me if I wore that dress or something like that. That type of thinking involves self-projection. You're imagining what to wear to a cocktail party, and you're imagining yourself at the cocktail party. The problem is that for many people, that type of self-projection can go off the rails and become rumination, obsessive self-concern, worry. And when that happens, this medial prefrontal network that involves the medial prefrontal cortex starts to go on overdrive. How do we deal with that? By entering the senses. When we enter the senses, that medial prefrontal network is decreased. And this is something that not only Norman Farb has shown in mindfulness meditators, this is something that brain scientists all over the world are discovering, that these two networks are in competition, and when you're engaged in a task like attention to sensations, you are actively decreasing that activation in that rumination network. Okay. So that answers one question: how does mindfulness reduce the risk of depression? Because we know that people who have a tendency to ruminate on past disappointments, worry obsessively about the future, that trait appears to make you much more likely to be depressed, and if you've already been depressed and recovered, you're more likely to relapse. And so one thing that mindfulness does, we think, is it reduces that tendency to ruminate, and one of the ways it does that is by encouraging you to focus close attention to your sensations, like sensations in the toe. So if you try doing that right now, you'll notice that if it involves some attentional effort. And it's that form of training and retraining that we think helps to reduce the risk of depression in people who undergo this, people who learn mindfulness. Okay, so let's just pause for a second and reflect on this. Take a breath, and if you want, focus on the sensations of the breath in the belly or somewhere else. And just let's think about what this close sensory attentional focus involves. What does it feel like? Okay? So I'm going to talk about before I talk about what I thought I was going to talk about, just think about how hard it is to have that judgmental voice when you're focusing really intently on your breath. Okay. So here's the second circuit. This is the thalamocortical circuit. And the idea here is that there's an area in the brain that sits beneath the cortex called the thalamus. And it's actually the sort of antechamber for the cortex. And all visual, auditory, and touch sensation has to go through the thalamus to get to the cortex. In order to be perceived, a touch sensation, a visual sensation has to go through this gatekeeper. Okay, the thalamus is the gatekeeper. So we set out to study the cortex and the thalamus using magnetoencephalography. And this is one of our subjects. She really enjoyed being in our study. And she's sitting in this copper-lined chamber that we used that also inside that sort of large hairdryer-looking contraption, there are 306 very fine superconducting sensors that are focused on an individual's brain. So what we looked at was the circuit between the thalamus and the cortex. And the reason we looked at that is because our hypothesis was that learning to regulate, and I'll unpack this in a second, learning to regulate body map thalamocortical neurons teaches you to regulate across the entire thalamocortical landscape. What does that mean? Learning to be mindful of the body teaches you to be mindful of other sensations, thoughts, and feelings. And our theory about the way it does that is you entrain the thalamus gatekeeper to be more efficient and to be more responsive to changes in context, moment-by-moment context that can happen as things change during the day. Okay, so the thalamus sits below the cortex, and what it does is it helps to edit the sensory stimuli that come into your brain. And this is because if the thalamus did not edit the sensory stimuli coming into your brain, you would be completely flooded with sensation. Basically, 85% of incoming sensory information is edited at the level of the thalamus. It never comes anywhere near awareness. And this is because there's just too much information, sensory information in the environment. The thalamus has to edit and sculpt and help you to choose what's important to focus on. And one of the ways that it does that is this thalamus cortex circuit actually controls what we're calling an editing rhythm called the alpha rhythm. And this alpha rhythm actually is different at many different places in your sensory maps in the cortex. By that I mean, if you feel your finger and the location in your finger in the brain is affected by your focus on your finger. And we just sort of wandered off into the weeds. So I'm going to return to this in a second. It'll be clearer what I mean. Okay. These alpha rhythms basically help you edit these incoming sensory streams. So if you look at this figure on the upper right, the human primary and secondary somatosensory cortex, this is a map of the surface of your body. Every body part is represented in the cortex. And this map is actually kind of oscillating 10 times per second. And this electrical current in the map is oscillating at 10 times per second, and that oscillation is called the alpha rhythm. If the oscillation is very, very large, then that area in the cortex is blocked or shut off. So this is what I mean by editing. The alpha rhythm is the editor. If it's a very large alpha rhythm, then that area is, sensation in that area is blocked. So if it's a really small alpha rhythm, sensation in that area is allowed through. So you have to think of the thalamus as this doorway or gatekeeper. It's deciding what sensations to let in. And that is then measured, that gatekeeper mechanism is this 10 times per second alpha rhythm. Okay, I'm going to make this a little more concrete and you'll see. So right now you're listening to my voice, I hope. And that means that your auditory areas, the alpha rhythm is low because the thalamus has made the decision, guided by your attention and interests, to prioritize my voice. What does this mean for the neurons representing your buttocks? Well, that's not a relevant information stream right now. So presumably, those neurons are actually have a very high alpha rhythm. So if you look at the slide, the buttocks neurons on the right have a higher alpha rhythm, and the auditory neurons on the left have a lower alpha rhythm. And so just by tweaking the height of that rhythm, basically the thalamus and the cortex are shutting off. They're turning down the volume on sensation. Okay, that's the model. Alpha rhythms help you decide what to see, what to hear, and what to feel. So we used the magnetoencephalography measure to look at alpha rhythms in the cortex. And what we did was we looked at the body map. And what we wanted to see was, could meditators control the volume knob to neurons representing sensation in the hands and the feet? Could they exercise finer control over those neurons after a course of meditation? In other words, can mindfulness teach you how to exercise very fine control over your sensory world, over what sensations are admitted into consciousness versus which sensations are blocked? And you can see how this would be very important. It's very obvious right now that maybe it's a good idea to listen to my voice. It's a good idea to turn the volume down on the buttocks. But you actually are making decisions like that. Your thalamus is making decisions like that throughout the day to prioritize a sensory stream. Let's say you're listening for your child who has a certain vocal frequency. That frequency will be prioritized. Or you actively need to block out some intrusive sounds. Those frequencies will be actually, the volume will be turned down. And you need to be able to control these volume knobs very dynamically throughout the course of the day as you move from one room to another, as you go from a very quiet room to a noisy room. All of these things have to be very dynamically controlled, and the question is, do meditators, people who learn mindfulness learn to exert more subtle, finer control over these sensory input streams? I hope this is making sense. Okay, so remember that instruction. Remember that how fine the level of detail is that mindfulness teaches you to focus on the sensations in your toes. Or in mindfulness-based cognitive therapy, you're taught to focus on very subtle sensations in the belly when you're breathing. And remember I asked, why? Why is there this focus on subtle sensations? And we think our hypothesis was that this focus on subtle sensations teaches you to regulate the body map better. The body scan, sitting meditation, teach you to be able to sweep your attention through the body map with better control over your alpha rhythms. Okay? That was our hypothesis. And it goes to this larger idea that the thalamus sits under the cortex, editing all of the sensory stimuli, and our idea is that mindfulness teaches people to have better moment-by-moment control over that editing mechanism. Now, I hope you can see that this would have very important implications for learning how to filter distractions, learning how to prioritize one sensory stream over another, very important implications for learning. And I'll talk about that at the end. Okay, so our experiment, we asked people to attend to either the hand or the foot, and we had them do this hundreds of times, attend hand, attend foot, attend hand, attend foot. We gave them that instruction, and then we measured the alpha rhythm in the brain's map of the hand. Okay, so we measured what happens to the neurons in the cortex that represent that finger when people are asked to attend either to the finger or away from the finger. Could practitioners show enhanced control over the 10 Hertz alpha rhythm in the body map? And you can think of this alpha rhythm, controlling the height of this alpha rhythm is sort of equivalent to a volume knob. It allows you to either turn up the volume or turn down the volume, depending on how your attention is focused. So we asked people to attend to the finger or attend away from the finger, and this is what we found. We found that meditators had better control over the neurons in the finger. They had better and faster control over those neurons. They could either turn the volume up or turn the volume down, depending on the instruction. They're not being touched. Nothing's happening to them on a sensory level. All of the control is taking place in the mind. They're using the mind to control the volume setting on their sensory neurons. And that volume setting is this alpha rhythm, the height of the alpha rhythm. Okay? So, the result that we found was that meditators were able to achieve earlier modulation of neurons and the neuronal responsiveness in a small area in the brain's map of the hand. And our larger framework here is that this attention to body sensations may be a useful doorway to mindfulness practice. What does that mean? Well, the hypothesis we're pursuing now, and there's very good evidence for this, suggests that this ability to control the volume knob in neurons that represent the body may generalize to the rest of the thalamocortical interaction, may generalize across the brain. In other words, better attentional control over sensory neurons may explain how mindfulness meditators achieve greater control over working memory and are able to more easily regulate emotions and cognitions. Okay, what do I mean here? It turns out that if I ask you to purposefully recollect where were your keys yesterday, and you're thinking back to your messy office, and your mind is sort of going over that scene. And let's say I ask you to think about maybe one part of your messy office, and to use your mind's eye to see if you could remember where your keys were in that part of the office. Very complex scene. It turns out that your ability to suppress or enhance the alpha rhythm in visual in visual areas in the brain is very related to your success in controlling those memory streams. I'll say that again. This alpha rhythm control is not just useful for present moment sensory attention, it's also useful for regulating your memory of the past, memory of past scenes. We also think that it may help you, raising the alpha rhythm in the auditory stream may help you as you're trying to get a visual memory. Or if you're just trying to remember a string of numbers, someone's phone number, being able to use the alpha rhythm to turn down the volume on sensory inputs is very important when you're trying to remember something. It turns out that control over these sensory areas is really important for cognition and working memory. Why does that matter? That matters because if you become depressed, if you develop chronic pain, your working memory starts to erode. And we know that mindfulness relieves distress in those situations and may help things like working memory, may just improve your cognition. But how would this sensory attentional training do that? Why would attention to the breath improve cognition and emotion regulation? What I'm describing to you here now is the neural model for understanding that, the answer to that question, which is learning how to focus on the breath gives you this control over your dynamics in the cortex that then can generalize to all sorts of cognitive and emotional regulatory tasks. Not only that, it may help you, if there are competing sensory memories, it may help you actually change channels from one memory to another. In other words, having this voluntary control over these volume knobs isn't just about being able to listen to my voice right now in the present moment. It may help you recall something from yesterday. And it may help you suppress if a memory stream starts to arise that's not useful, that's not skillful in helping you in your present moment focus, then this alpha rhythm could actually help you suppress that memory, this alpha rhythm control. One of the ways it may do that is by directly competing with memory streams. If you focus on your breath, guess what? It's very hard to have a negative rumination. Okay, so I've described a second circuit, which is this thalamocortical circuit, and what I've really tried to establish is the relevance of sensory attentional processing for well-being. And let me talk a little bit about the relevance of sensory attentional processing for learning. Working memory and processes related to working memory is critical for being able to take in a complex series of information, for being able to handle information that involves multiple parts that you have to kind of hold in mind at once. The ability to use alpha to, help adjust the volume on your sensory cortices. We know that that is highly related to your ability to perform working memory tasks. And we know that working memory is very important. Development of working memory is very important for learning complex tasks, complex concepts that have multiple parts, concepts that have to be held in mind and applied to other concepts. So we think that this sensory attentional learning that takes place in basic mindfulness training, attend to your breath, attend to the sensory details of your breath, this may have real importance for higher learning processes. Okay. It may also help people who are working with negative mood or pain. we know that people who have negative mood have all sorts of negative attentional biases. And just being able to go through and sweep your attention through the body map may help you learn what it's like to reduce attentional bias. In chronic pain, sweeping through the body map in something like a body scan will include focusing on a painful area. By learning to focus on the painful area, you can actually start to reverse attentional bias. So let me talk about that for a second. Remember, the basic idea here is that if you did not have this thalamus cortex editing system, you would be overwhelmed with stimuli and sensory information. It's the thalamocortical editing that makes it so you can get through the day and not feel overwhelmed with distraction. How is that relevant to the concepts of body, space, and presence? This is sort of a wrap-up now. I know we're getting near the end, but I'm going to describe this briefly. So meditators in our study described very subtle body sensations during the body scan and sitting meditation. Remember, one practitioner noted that her nostrils felt cold when breathing during meditation. Now think about the level of detail that's required to feel that, and then to feel that that's the one of the most salient events that happened during your 30-minute practice. The thing that you most want to record, that the nostrils felt cold when breathing. Very interesting that somebody would feel that that was what they wanted to highlight. In our study, and in others, subjects report becoming more aware of the inner space of the body. I'm calling this kind of a body space landscape that has emotional and cognitive sort of memory resonance. So attending to the body, attending to palpable sensations during body scan. Why does mindfulness practice so invariably start with the body? Here's one answer to that question. This is really interesting. Okay, so if you focus on the sensations in your toes, okay, go ahead and do that. Now switch your focus to focus on the sensations in your left fingers. Okay. Some of you may actually feel sensations in your hands and fingers when that attentional shift happens. If you do feel it, and many meditators report feeling it, many normal people report feeling a kind of actual sensory percept when they focus on the body, when they focus on the fingers or the toes. If you feel that, what we think is you are learning to feel your own cortical rhythms. You're actually learning to feel and train your alpha rhythm volume knob. That's one thing that may have been available to these early yogis who learned to focus on very highly detailed sensation. And in the Buddha's time, or in other arts like yoga or Tai Chi, learning how to do this kind of close attentional focus, you can think of it as the first group of people who learned how to do brain training, because you do learn to feel your own cortical rhythms when you do that. And actually, what neuroscientists are finding now is that this sensory attentional focus can be highly useful if you're trying to do a brain-computer interface. I'm not going to talk about that anymore. All right, so that's one answer. The other answer is that you learn to feel your emotions in specific body areas. So one of our practitioners reported that she had emotions of anger in the pelvic area, happiness in the stomach, and sadness to the point of crying in my hands. So one of the things that may happen is that certain body locations get associated with certain emotions. And sweeping the attention through the body space gives practitioners the ability to control the volume of these neurons, and it gives them the ability to exercise much finer control, possibly, over some of these sensory emotional associations. And the way that we're framing that is that one way to think about that is that sweeping the attention through the body, learning how to control the volume knob on these neurons may give people more attentional freedom. Okay. And that's attentional freedom may have implications for understanding presence. Presence here means that you can rest your mind in the body space without aversion or reactivity. Now we know in chronic pain there can be a loss of presence. People they start avoiding body sensations. They avoid even light touch sensations. And we think that this gives them poor control over their alpha rhythms. They lose this free access to the body space. And we think this may relate to their loss of the ability to be present. So the idea here is that learning how to sweep your mind through the body may be able to restore some of that presence. Now we have data from one subject who had chronic pelvic pain, and unlike all of our other subjects who increased the connection between the prefrontal cortex and the sensory map of the finger, this person actually decreased the attentional control. She actually, when we asked people to turn the volume up in the finger, her prefrontal cortex actually tried to turn the volume down. And so what this suggests to us is that in cases like chronic pain, there is maybe profound dysregulation over control over these sensory neurons. We also think that's true in ADHD, and there's some good data to back this up. People can ask us about that. So I think we're heading into the final stretch. The implications for contemplative education are, when you sit with other people, sometimes you can feel whether they're present. It may be useful to think of a lack of presence as attentional avoidance at the level of sensory processing in the sensory attentional networks. I'm going to leave that. Let's all focus on our breath for a second, or a minute, or some length of time. See if you can feel in a detailed way sensations of the body and sensations of breathing. Oops. So this mindful focus on body sensations may help students learn control over this thalamocortical editing mechanism, give them better control over sensory, emotional, and cognitive processes. It may also facilitate emotion perception and discharge. And it might help us be more present, and it might help our students be more present in this body space, in the present moment, without reactivity or aversion. We're trying to see if we can operationalize this in brief mindfulness training for medical students, and see if this helps them feel more present and more better control over their information processing, and just more able to learn. So that's what we're doing with these very brief sensory attentional training for professionals. And the idea is to just strip away a lot of the kind of jargon about meditation and teach people to gain direct sensory access to sensations in a quiet way. That might hold the key for all these other gains. And it's something that can be taught in a fairly immediate way that people understand. That's our theory. So let me just thank everyone. My neuroscience mentor was Christopher Moore at MIT. These are all the people who helped out on my study. It takes a village to do a study, and these are my contemplative studies collaborators here at Brown. I also worked with Sarah Lazar and Ted Kapchik up at Harvard. Thank you. Here's my contact info, and I guess what I'll do now is turn it back over to maybe people have questions,
That's
and
perfect.
then I'll read the answers. You can read them out and see what people think.
Yeah,
Great.
it is a good time now. We can open up the questions, and if you want to take a look at those, take a moment to do it. I just wanted to say one more thing about the talk, and
Oh, sure.
perhaps others will will want to comment on this too, is interesting that it really makes us aware of how valuable this attention to the body space is. And I think typically when a lot of people are taught any kind of meditation, you know, the sort of settling the body or the body scan is meant to just kind of be a way to quiet it down so that the brain can meditate. But, you know, this really makes us aware of how much the actual attention to the body is
well, this is actually supported very closely by early Pali Canon suttas. They talk about being able to work with the breath can take you very, very far in your practice. Being able to work directly with body sensations, you can go all the way.
It's wonderful.
Just noticing that.
Can you see them, Carrie? Do you want to read one?
Okay, here's a question. Could you come back to the issue of chronic pain? Did your subject do a general body scan or focus directly on the pain region? Some would say focusing on somatic experiences would increase pain sensations.
Yes. Focusing on somatic experiences could increase pain sensations, and because of that, what happens is that pain patients develop pervasive attentional biases, so that and it depends on the person, it can either be attentional bias towards the pain, which is most people, or attentional bias away from the pain. But what happens is you get these biases, you get these kind of permanent changes in the volume knobs, and you actually lose dynamic control over, you can't adjust in a moment-by-moment way because of these attentional biases. And so what you see is that people with chronic pain actually have decreased working memory, decreased attentional function, and just generally poorer signal processing because their systems are stuck, either attending towards the pain or attending away from the pain. And if they can learn how to debias the system, then that can be very helpful, and it may be why mindfulness training is so helpful for people with serious chronic pain. It doesn't actually necessarily reduce pain intensity. What it seems to do is to have a huge impact on distress and on the experience of the pain. Does that make sense?
That's helpful.
Yes.
I'll read one. Here's from Al Kazniak. In learning and generalizing the skill of sensory attentional modulation, is there evidence that there is something special about mindfulness practice focusing on bodily sensation? Or would similar learning and generalization be expected by a focus on distal sensory processing, such as vision or audition?
Well, that's a really interesting question, Al, and is very timely. There is evidence, actually, that certain video games can increase, that can produce increased attentional performance, and not just in the domain that the video game was trained. But so there is evidence that a kind of more straightforward attentional training that involved, rewards and games or whatever the training tools currently use might also have similar benefits. But there's actually, it's a little complicated, but there's a bunch of reasons to think that mindfulness training may generalize more than these other forms of training. First of all, the way that you're rewarded for your attentional practice is very different in a video game versus where you get points and you kill things versus in mindfulness training. And being able to make it so that reward is not driving where you put your attention may be very, very important for well-being and for this sort of broader debiasing of the attentional system that we're talking about. And that's something to think about, like how much of our attentional system when we get home and watch TV and eat is driven by reward salience. And that's what makes mindfulness really interesting and possibly exceptional, is that it it has a very different relationship to reward. The other thing is that the body may be a really special place for carrying out this sensory attentional training because it's so palpably present and behaviorally relevant, and because we can feel it. We get a sensory response often when we attend to our toes. We don't get that same response when we attend to the wall. There's a way in which we're both the subject and the object, and we're the perceiver and the perceived, and that may give us more insight into the perceptual process, if that makes sense.
Yeah. Thank you. Yeah, the metacognition, right, with any kind of mindfulness, that's something that's people have been talking about, the difference between, you know, developing attention by using video games.
Right, yeah, I don't think the current generation of video games teaches people to notice where they're attending to or what they're thinking about in the same way that mindfulness does.
Yeah.
And in a way, I mean, Jon Kabat-Zinn always says, like, do the body scan, but it's not about the body. For him, it's about having this place where you really can see the workings of your mind up close. And that might be something that body-focused attention is really palpable, and we can see the attentional focus. We can learn to see the mind and feel it in this really palpable way.
Wonderful. Well, a number of people are asking for more information about the very suggestive remark you made about ADHD. Another person is interested in the specific meditative activities you're using with the medical students, and I assume that's what your current research about these busy professionals trying to do it in a New York minute kind of thing. So I wonder if you wanted to address those briefly, and then we probably can't take any more questions for this webinar, but we will have a printout of the questions, and if there are additional ones you'd like to address, we can post those with the webinar.
So that was the busy professionals, and what was the one?
Yeah, one was just the activities that you're using in this research, the meditative activities with the medical students. And then the other was anything you can say about the ADHD.
Well, the ADHD, actually, they have actually looked at these alpha measures in kids with ADHD, and they are abnormal. Their ability to modulate alpha rhythms is abnormal, and that's precisely what we'd expect. They don't have good control over these volume knobs. And it's reassuring that they did find that, because we would have strongly hypothesized that. So, and we also know from some emerging research that this type of sensory focus and mindfulness more generally is useful for kids with ADHD. It appears to be useful. And so that might be one mechanism, one way that sort of the underlying brain mechanism, the change that's being accomplished. But we haven't looked at that directly. The second thing is we're really interested in the information processing in medical students who are just flooded with having to process incredible amounts of information, and processing of distress in residents. It turns out that residents are distressed a lot of the day, and this may be directly affecting their ability to care for patients. So what we want to find out is whether brief mindfulness training, we're talking like 3 to 5 minutes, after distressing patient encounters and at the beginning of the day, can help to reduce that distress and stress response that people in really busy clinical situations, are seeing just churning patients in often difficult patient populations, whether they can kind of stop that upward climb of the distress cycle and interrupt it by doing brief mindfulness training.
Wonderful. So we'll look forward to hearing the results of that study, Kathy.
Right.
And thank you so much for taking on the questions that you did take on, and sorry it was a little awkward getting at them.
No, it was like radio. Thanks, everyone. I appreciate everyone being here, and contact me at my contact info, which is Catherine_Kerr at brown.edu if you have any other questions. Thanks. Great
Thanks
to meet
so much.
everyone.
Great, and I'll just say thank you to everybody who attended too. We had about 137 people logged on today, so it was a really well-attended webinar.
Awesome.
Really appreciate your participation. And I just want to point us in the direction of our next webinar, which will be with Rhonda McGee, who's Professor of Law at University of San Francisco. She's also the president of the board here at Contemplative Mind, and she will give a talk on Wednesday, May 16th. The title is to be announced, but we'll have details and registration on the website soon and send out an email invitation to you all. So I hope you'll be able to join us in May. But for now, farewell until we meet again. Bye-bye.
Bye-bye.